In this video, we're going to look at the introduction of what is statistics, and we're going to look at data and some terminology of data collection. So just to begin with a definition of statistics, statistics is collecting, organizing, displaying, summarizing, and making predictions from data. So we're going to kind of look at all of those aspects throughout the course. So how do we collect data appropriately so that we can make valid conclusions from it? Once we have that data, how do we organize it? How do we display it, which is talking about mostly making a graph of it? How do we summarize it? So we can do numerical summaries of statistics. Some things you're familiar with, the mean, the median, the mode, things like that. Some things maybe you haven't talked about before, such as standard deviation and interquartile range. And then once we have all of that, we want to be able to make predictions from that data. So, data is numbers or qualities in context. So, just having a list of numbers or a list of information is not considered data unless you know where that data came from and what it's representing and what its units are, if it's numerical, things like that. So data must tell us two things, and the first is the what we refer to as the who. So what is my sample and or my population? So from whom am I getting data, or from what am I getting the data? The second thing that we have to know is the what, or what variables are recorded and or measured. So what information are we getting, and who are we getting it from, or what are we getting it from? Those two things have to be clear in the data. So if you look at the two examples here, so in the first one, we have some data. So we got students from Penn State, so that is my who, reported their weight, and that is my what. So my variable is weight, so it was measured, and it was measured from the students who are in this class at Penn State. So this information here would be considered data. Over here, this is not data, because although it is a list of numbers, we don't know what it represents. It could represent the number of days someone went to the pool in the summer. It could represent the number of books someone's read. It could represent how long it took people to accomplish a particular task. We have no idea. So without that information, we would not consider it data. Ideally, we would also like to know from data when, where, why, and how. So we would like that information. So for example, with the data on the Penn State students' weight, we don't know when this data was collected. We do know that it was collected at Penn State. We don't know why it was collected. So the graphic is kind of talking about student self-reporting. So that's important to know, because perhaps if people are self-reporting their weight, it is not as accurate if each individual were weighed. So looking a little bit more closely at the who of the data. So the who, remember, is my sample or my population. Sometimes those two things are the same. Oftentimes they are not. So my population is everyone or everything from whom we would like to collect the data. My sampling frame is the people or objects available when we actually collect the data. And then my sample is the people or objects from whom we actually collect the data. So let's say, for example, we want to collect information from all MND students. So our population is all MND students. Now, we don't have the time to get our information or our data from all MND students. So instead of actually getting the information from every single student, we're going to take a sample of students and use that for our data. So let's say one day we are going to collect our data from students who are at school on that day. So obviously not every student is at school every single day. So my sampling frame would be the students who are at school on the particular day that we collect the information. And still, it's too time consuming to get the information from all of the students who are actually in the building on this particular day. So we're going to take a sample. So maybe during block 3-4, we randomly choose 5 students from every classroom. And then that would be our sample. So the students that we actually survey is the sample. So we would always like to get data from our population, but most times it is either too time consuming or expensive or just impossible. So then we're going to look at the sampling frame, which is the people from which we can choose to get information. And then we're going to make a selection from that, preferably a random selection. So the what of the data, remember, is the variables and the information that we collect using those variables. So a variable is anything that can take on different options. So in your typical math classes of algebra, geometry, calculus, etc., A variable was usually a letter that represented a value that you were solving for, and typically that was coming down to x equals a given number or maybe two numbers. Occasionally, there might have been infinitely many possibilities for that value. But in our case of statistics, a variable is just anything that can take on different qualities or different measurements. And there are basically two different types of data. Data can be categorical, or sometimes we refer to it as qualitative, and then data can be quantitative, or sometimes people will refer to it as numeric. Categorical or qualitative data are variables that have labels for options. So something like eye color or religious affiliation or grade level or zip code. So a zip code is numeric, but it is not considered quantitative. It's just a label that happens to use digits instead of letters. So if we ask a person their favorite color or their favorite sport, those would be categorical or qualitative. When we refer to quantitative data, we're referring to numeric data that has two properties. First of all, it has units, and second of all, it can be used to perform meaningful calculations. So if we go back to the example of zip code before, zip code is numeric, but it is not considered quantitative data. So I cannot take a zip code, say, and multiply it by 2 and then get a new zip code that would be twice the distance from the equator as the first one. So we have to be able to do meaningful calculations with it, and we have to know what its units are in order for us to consider data to be quantitative. So, some more terminology here. We have parameters and we have statistics. So, parameters are calculations made from population values, and statistics are calculations made from sample values. So, there's a bit of alliteration going on here. So, parameters are calculated from population values, statistics are calculated from sample values. So, that should help you remember the two. Typically, we cannot calculate the parameters because we don't have population values, but we can calculate statistics from our sample, and then we make inferences about the parameters from the statistics. The goal of a sample is to be representative of the population. We can never necessarily get a sample that is exactly perfectly representative of our population, but our goal is to get as close as possible. In order to do that, we want the sample to be both heterogeneous and random. So we want our selection of our individuals to be random, and we want to make sure that they are heterogeneous, meaning they include all types of objects or people who are contained in our population. So, for example, if we go back to our situation where we were trying to do a survey of students in the school building, and if we only chose to speak with freshmen, then that would be not be a heterogeneous sample. So, what we would want to do is make sure that our sampling frame included students of all grade levels. And then, if we then chose randomly from that sampling frame, we should get a sample that includes students of all grade level. It's possible that we would still not have that happen, but there are also some procedures that we can do to kind of make sure that that happens. So, looking at some different types of sampling, the first is called a simple random sample, and we abbreviate that usually SRS. So, in a simple random sample, every individual has the same probability of being selected. And additionally, every group has the same probability of being selected. So if you think of a list of like alphabetical list of all the students in the school, we would want to make sure that every student has exactly the same chance of being selected. So let's say for ease, there's 800 students in the building. Each person has exactly 1 in 800 of being selected. So that means that what we have to do is sample with replacement. So every time we choose a student, we put that student's name back in when we make the second selection. We also need to make sure that every group has the same possibility of being selected. So that means that if we're looking for 100 students, the first 100 students have to have a possibility of being selected together as a group. So in some of our other techniques, that would not be possible. So the simple random sample has those two qualities. Every individual has to have the same probability, and every group has to have the same probability of being selected. A second sampling technique is called stratified sampling, and this is where we organize the population into homogeneous groups by some characteristic, and then we take a simple random sample from each group. So again, if we go back to choosing a sample from the student body, if we take the list of all of the freshmen and a list of all the sophomores and a list of all the juniors and a list of all the seniors, and we take a simple random sample from each of those lists, then that would be stratified sampling. So we've divided the population into homogeneous groups that we have characterized by grade level. And then from each of those groups, we're going to choose a simple random sample. So this deviates from the simple random sample because remember, every group has to have the same possibility of being selected. But in this method, a group that it contains all seniors would not have the same probability of being selected because we're forcing ourselves here to have a sample that has students from every grade level. We would tend to use this stratified sampling when we know that there is perhaps some identifiable difference of answers in the grade levels. So if we want to make sure that we want to be able to identify those differences, we can do this stratified sampling. Another technique is called cluster sampling. This is where we group the population into heterogeneous groups and select one or more of the groups. So for example, in our desire to get a sample of students from the building, we could perhaps choose one lunch period and go and survey people, every person in that lunch group. The key distinction between stratified sampling and cluster sampling are two things. So, in stratified sampling, you're going to have groups and you're going to choose a simple random sample from each group. In cluster sampling, you're going to have groups. You're going to survey every person in that group. So in the stratified, we're going to choose from each of the groups. In the cluster sampling, we're just going to select one group. The other distinction is in the groupings. So in a stratified sampling, you're creating groups based on a characteristic, for example, grade level or age or gender. In cluster sampling, you're going to have heterogeneous groups. So you want to have groups that are created and have all types of people that could be in your population in that group. So in our example, we're going to have to go with the assumption that um, our lunch periods would contain students from every grade level, from each academic level, all types of bus riders versus non-bus riders, athletes versus non-athletes. Another type of sampling is called systematic sampling, and this is where we would take every nth person on a list. So maybe in our surveying of the student body, we would get an alphabetical list of every student in the school. We would then take every 80th person. In order to make it more random, we would choose a random number to start with. Instead of starting at the first person, we would choose a random place in the list to start with. And then from that point on, we would choose every nth person, depending upon how many we needed. So remember when we talked about simple random sample, every group has to have the same possibility of being selected. In a systematic sample, students who are alphabetically next to each other in the alphabetical listing would not necessarily have the same probability of being selected. Multi-stage sampling is when we combine one or more methods. So perhaps we use stratified sampling and we divide the school population into their grade levels of freshman, sophomore, junior, senior. And then from each of those, we take an alphabetical listing and choose every 20th student on the list, starting at a random place. So then we've used stratified sampling combined with systematic sampling. So we can combine some methods together to help us get our sampling. Our last method is convenience sampling, and this is where we take people who are conveniently available. If we want to make valid statistical conclusions from our data, then we need to make sure that we're using a sampling technique that is valid. So a simple random sample is valid, a stratified sample, a cluster sample, a systematic sample, and a multi-stage sample are all valid options. We have to pay attention to the situation to see if all of those would be valid in every situation, but those are predominantly considered valid ways to sample that we could then make conclusions from our data. A convenience sample is not considered a statistically sound sampling technique from which we can make valid statistical conclusions. All right, so here just looking at some examples of sampling methods. So we need to survey a random sample of 300 passengers on a flight from San Francisco to Tokyo. So if we pick every 10th passenger as they board the plane, so this would be systematic sampling. So we have a line of people in essence as they get on the plane, and we're going to choose every 10th passenger. From the boarding list, we randomly choose 5 people from the first class section and 25 people, or 25 of the other passengers. This would be stratified sampling because we have people who are in the first class section and then people who are in the coach or business class section. And then we're choosing randomly from those people. So we're choosing 5 from the first class and 25 from the other passengers. So notice that the number of people does not need to be the same from each group because there are fewer first class passengers than other passengers. It's okay to have a different number there. In C, we're going to randomly generate 30 seat numbers and survey the passengers who are in those seats. So this is a simple random sample from the entire population of the passengers who are on this flight. We are going to randomly choose 30. And finally, we are going to randomly select a seat position, right window, right center, right aisle, etc., and survey all passengers sitting in those seats. So this is an example of cluster sampling. So we have these groups which are sort of already forced on us geographically. And then we're going to choose one of those particular groups and we're going to survey all of the people who are contained within that group. So remember in cluster sampling, we're going to choose a group and survey everyone from the group. In stratified sampling, we're going to have different groups and we're going to choose from each group. So finally, regardless of our sampling method, we could end up with some type of bias. So bias is any systematic failure of the sample to represent the data. There are several types of bias that we want to be able to identify. The first is voluntary response bias, and this is where the respondents can choose whether or not to participate. So this is an example of sometimes you might get emailed a survey after you take a class or you go to a workshop or you have a service done at a salon and they say, will you complete this survey? And you can choose whether or not to do that. Under coverage bias is when we systematically leave out part of the population. If we're trying to get a sample of students from the school building, but we choose not to survey any freshmen, then we have systematically left them out of our sample. And so we have left out part of our population. Non response bias is when a large number of people do not respond. So, non response bias is sort of connected to voluntary response bias a lot of the time. If you can choose whether or not to participate, then if a lot of people choose not to participate, then you have created non response bias. And finally, we have response bias, which is anything about the survey or the environment that can affect the results. So this cartoon here kind of gives you a little indication of response bias. So in this particular situation, someone from the King's uh, employees is asking about rating the King's job performance. And the options are good job, outstanding job, or terrific job. So the survey itself is biased because it does not allow for you to say that the king is not doing a good job. And also having that person who works for the king ask you that question is a bit of response bias as well because um, that can affect the results.